welcome to Rob's Fix-It Shop. Tonight in the shop I have a Kenwood KR 2090, and I picked this up somewhere. Very inexpensive. I kind of like the Kenwoods because they're right in my price range. And I don't know if there's anything wrong with it. This knob here is funky, but from other than that, I don't know if there's anything wrong with it. But I thought it'd be fun to kind of open it up and take a look at it. It's from 1978, which I think is the golden age of stereos. But that's because that's when I was a kid and I loved to look at them and lust over them at the stereo store. So yeah, so let's open it up and take a look and see what's in here. I think it's only like 16 or 18 watts per channel. But I don't know, it'll be fun to look at it. So let's just take a look around here. It's a very simple stereo, right? Looks like it does come on. Kind of attractive in its simplicity. I think this was kind of the low end of the model for that year. It's got the metal case. I think you could buy it with a wooden case. Take this out of here. Take a look around the back. Yeah, looks pretty good. All right, well, let's open it up. Well, how's that for simplicity? Yeah, so this is messed up. The tuning looks like that got dropped or bent or something. I'll have to fix that. And there are the power transistors down there. I don't know. All right, heatsink. Not great. I don't know what kind of transistors those are. I can't see from here. But that looks like the phono section there. Well, let's try powering it up. So this stereo's got the same weird where this is speaker A, left and right. And most of them are like A, left and right, B, left and right. I don't know. That's just weird Kenwood stuff. All right, so let's just have 1 kilohertz and we'll put it at 300 millivolts peak to peak. A little low. And then I've got my scope. Watching both channels. Okay, so then we'll turn it up. Put it on my dummy load so I don't blow my ears out. So our one channel is about 7 volts RMS and the other one is 5. Let's check that out. So 7 times 7 divided by 8. Huh. That doesn't seem right. That seems kind of low. Take one of these off. Let me see here. Let me turn the bass and treble to the center. Balance in the middle. Okay, that's better. So at 11.8, squared divided by 8. So that's 17 watts. That's what it, 17 and a half. That's right, what it's advertised at. And we are seeing a little bit high. Okay, that's the one channel. Let's try the other channel. So the other one seems lower. Oh, it's higher. So put it back. Yeah, just slightly. Interesting. It's warming up. I don't know. It does look a little. I mean, obviously, look at the controls. It's really got this weird setup on the controls. A bass and treble, and then balance is right next to the volume, right? And the volume's way over here. Usually, it doesn't seem like it's usually over on this side. That's all right. The other weird thing is that your power and your speakers are all on the same switch, but your first switch here is phones, which to me, I think that's kind of weird. Okay, so now we're going to put a square wave through it just to see, get a quick look at the frequency response. Oh, that looks pretty good. I'm not sure what's going on there. That could actually be my scope probe. Let me check that out. So it looks like our frequency response is really good, right? It looks, I mean, if like, let me turn down the treble or the treble. See what it looks like when your treble is down. And then here's turning the bass up, turning the bass down, right? But there's notches on these knobs, right, for the center. And it looks really flat along the center. Well, let's see how it sounds here. Okay, so right now, and you can look up here and see the frequency, but I'm at 1 kilohertz. And so then let's go down to 20 hertz. make that look a little bit better. And you see at 20 hertz, it's kind of attenuated. And then 30, 40, right around 60, we're kind of coming up. Then we get up. And we're at 1 kilohertz. And so then, so it's 1 kilohertz, 2, 3, 4, 5. And we get to 10, and it's like we get to 10, then we start kind of attenuating a little bit. All right, it's pretty good. So I think I want to, I want to recap. This is the amplifier section here, including the preamp. And so, although, I don't know, it does seem like some of the preamp stuff is in here, like the selector. But, well, here's the phono preamp. And then I think it comes through this control here, and then through here into the main amp. And so I want to recap that main amp. And but you can't get to it from the bottom. So I'm going to try pulling these screws, but I do have to, take off the knobs and stuff, because I think you have to take this face off to get the screws off to get this out. So it's going to be a bit of a lot of work for a recap, but it'll be kind of fun to see, take it apart and take a closer look at it. I'll just get these in the ultrasonic cleaner. That's kind of interesting. The glass is actually on here, and then these switches attached to are glued to the front. This connector here, so once you get the solder off, then this connector just kind of pulls back like that and leaves those pins. Kind of nice. I thought they went all the way through. I wasn't sure how to get it off, but yeah. So I think all I have left are the nuts on the front. So I got the whole board out, but I had a choice. I could have I loosened up the transformer, which is nice and heavy, or I could have just undone the wires here, but I thought it'd be easier to just unscrew this, and it turned out it was, and that gave me enough room to move it back. Yeah, so now it's inspection time, so I'm just gonna make sure there's no solder cracks on any of these. It didn't seem to be, but it's always worth looking at those because they get a lot of flexing. Yeah, but then I'm just going to pull the capacitors and I'll put in new ones. And it doesn't look like there are very many, right? Some in here, 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 some fancy ones. Yeah, well, I'll just get started on that. And there's nothing fancy that I do. I'm just going to take them out one at a time and put them back one at a time. And one thing I like to do is, before doing this, is put a mark on the capacitor towards the front. And then if there were the case where the circuit wasn't marked, then you can always know how to orient the capacitor. Usually they're marked though, so it's not a big deal. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16, not too shabby. Well, I guess that's most of the recap. I got to clean this up a little bit. I cleaned the controls, but there's still gook all over it. But one thing I found is that I've got these, they look like they're bipolar. 10 microfarad bipolar caps. And I didn't have any of those in stock. And then the 33s I put in here are not audio quality, I guess. But so I think I might order those parts. But I think in the meantime, I'm going to see if I can fix this guy here. This knob here is all funky. Looks like it got bent over. It's kind of cockeyed like that. And the whole thing is bent. Yeah, I'm going to take a look at it and see if I can fix it without taking it all apart, but we'll see. Now these caps that are on the power supply, I mean, they look pretty good. They're high quality Nippon Chemicon, and and I was thinking of leaving them, but then I kind of looked down here, flip this over. Here you can see it's kind of a weird gross residue down here, and once you pull them out, you can see that in here too. So I'm just kind of taking the glue off. I ordered some new caps. It's a little hard to find them with the right pin spacing, but like on DigiKey, it makes it kind of easy. You can like search. You can put one of your criteria be the pin spacing, but then I ended up having to get a cap that was a bit higher. I think these are 47 and I got 68 100, which should be fine. This is a pretty good size transformer. So yeah, so I don't know. They tested out pretty good. This one seems a little bit low, but the other parts of it seem pretty good. So I don't know whether I had to replace them. That gooky stuff seems kind of troubling though. So I'm replacing them. And then I've got a hot air gun that this glue is really on there. So I just take the hot air gun and warm the glue up. And then it comes off. Without too much problem. All right, so I'm going to pull this board here, and I don't want this to get off more than it has to, so I'm going to mark its position. Right. And then see if I can get some tape. I don't know. I hope this works, but tape the strings in place. And I also have to do that over here. All right, so then let me see if I can get this screw out. It does come out. That went better than I thought. Okay. So I think I just have to take out these here, the nuts in the front, and whatever's holding this in. And I think I should be able to take this board out. I think this back has to come completely off. Okay, back completely off. Now I should be able to slip that out, I hope. Well, that was a lot of work. I don't know if it's worth it either, but I thought it'd be fun to get it out, figure out how to do it. All right, so here we have our bipolar 10 microfarad caps. They go in the kind of the base circuit right here. And originally I thought, oh, I just put regular caps in, but they were bipolar before, so or non-polar. And so I'm going to put those in there. And then I got, so these are the caps that were in the power supply, and one of them looked like it was leaking. So I got some replacements, and really took a little bit to find them, but I wanted to kind of match the pin spacing so I wouldn't have to mangle the board. And these look like they fit right in, which is really nice. But to get the right pin spacing, I went up to 6800, which is fine, right? And then maybe a little bit better, but look at the size difference in those two. But okay, so I'm going to get going. I'm going to solder those in. Going to get these caps right, and then over here I've got a couple of 0.47 electrolytics, and I'm going to replace those with some polyester caps. And then I'm going to be done with the recap, and I can start assembling this whole big mess. Yeah, so here, something was leaking here because look at this is all kind of really crusty down here. I'm just going to clean that off as best I can, just with some alcohol. All right. So I was going to try to align this, and of course I marked the pull string when I took it off and put the tape on it, and then I cleaned off the mark with alcohol when I was using alcohol. So our alignment's kind of off. I got it as close as I could, but so we're just going to go through the alignment instructions, and I'm not an expert on aligning the FM section, but I can follow directions. So the first thing we want to do is we want to get a 95 megahertz signal with 1 kilohertz sine wave, and set our receiver to 95 megahertz, which I'm off, so I'm going to get it as close as I can. And then we'll go to the output B, which is just the speaker or the tape out. And then we adjust LG5. And I think if we look, LG5 is this guy back here. All right, so our first step is to work on the IFT. And so it says set the signal generator 95 megahertz, 1 kilohertz audio coming out of it, and set the receiver to 95. I'm just setting it to pick up the signal, and then adjust LG5. And LG5 is this guy back here. It says it in the service manual where it is. And what I found works best for this, if we look at the scope, what I found works best for this is you just turn it down. Right? Turn it down all the way, and then just kind of tune it. Bring in the signal the best you can. Right? And then turn it down, and then just try to adjust it again. And what the manual is saying to do is to check for distortion. So our next thing we want to look at is discriminator. And first we want to just make sure our meter is right in the center when we're in between a station. So I'm going to turn it between stations. Okay, so, all right, so let's take a look at that. And for that, we want to adjust LG7. Yeah, that's really in there too. Okay, I think that's as good as that's going to get. It still looks kind of off. Seems not the greatest. Oh, there we go. Oh, okay. A little bit more. Okay, that looks perfect. All right, but that's kind of the problem is that that plug started chipping a little bit. All right. Okay, so here we've tuned in the station. I'm just going to put it on my dummy load. And so we're just going to adjust this for maximum signal. And lowest distortion. So I'm gonna leave it right there. So our next test is tracking, which is way off. And so we're going to set it to 90 megahertz. And we're going to change LG 1, 2, and 4 with the muting off. And we want maximum waveform. So that's this, and that. No. No. Here's 1, 2, and 4. Okay, so let's look at this already. Okay, here's a good chapter in stereo repair stupidity. I was just wondering why it seems so far off, right? It shouldn't be that far off because I really didn't I recapped this, but I didn't really mess with very much. And but it was like really far off. And when I've been doing that other stuff, I had it at 98, which is right the center of the dial, right? And yeah, then the further I got away from the center, the further off it was. And I'm listening to a station all the way down here, and it announced that it was 108, which is the other end of the dial. Well, it turned out I had this upside down, so when it was actually going the opposite direction of what it was supposed to. And so, yeah, and so now that I got it on the right direction, we're actually pretty close in our in where our stations are at. So, whoops. And if you look at, yeah, here it shows the dial cord. It goes over each other, and I had it flipped so it just went straight around, and which meant that it went the wrong direction. Well, live and learn. Okay, so I got my signal generator set back to 90. We're going to tune our dial to 90, and we're just off a little bit, not very much. So, said to adjust this one, and this one to get that right. So I'm going to move it closer to 90 and see if I can turn this. Nope, that doesn't seem to have an effect. Nothing. So it really looks like these two here are the ones that are kind of getting it. Our tuning thing is not in the center. See if this makes a difference there. Yeah, so that adjusts where when I adjusted that, then the tuning needle came to the center. Okay, so now that we've done that, now we have to go up to 106. Okay, so we're kind of far off up here. So I have it set at 108, and we want to adjust here, and then the little cap there. I don't know, let's just see what difference this can make. going to use your Bank of America Cash Rewards credit card. That looks about right. Now let's turn it back to 88. See how far off that is. Well, it looks like I got everything done. I wanted to look at a couple of things. Here's the here's the specs, and it looks like it's 0.1%. So the other thing I was looking at is the frequency response, and that's right here. We've got from 20 hertz to 50,000 hertz, plus 0.5 dB to minus 1 dB. And so I thought I'd take a look at that and see how close we are. So it looked like it promised about half a decibel. And right now I'm going from 0 to 25 kilohertz. And if I hit start, you can see it looks pretty nice. This is 1 decibel scale. Little jump right here. Let me switch to logarithmic. And we're really zooming in here, so it's really looking nice. And then we stay very flat. Yeah, so this is really a nice flat response, and it looks really close to what they're advertising. Let's try, let me just show you what happens when I turn the bass up, or I'll turn the loudness on. So that's loudness. And I'm off my scale here. So when I turn the loudness on, right up until we get about 1.2 kilohertz, we've got about a 1, 2, 3, about a 10 decibel jump on our signal. And loudness control plus 10 decibels at 100 hertz. So that looks like it looks like it's running right to spec. So that's cool. Let me try turning the treble way up. Yes, that's with the treble turned way up. Now let me turn the bass up for some craziness. Yeah, so it looks pretty great. Yeah, so now let's try looking at the distortion. Okay, so this is at 1 watt, and let's average. So 0.15, I think that's pretty good. It's pretty close to what's advertised. Now I'm going to turn it up to the 18 watts, which would be 12 volts RMS. And yeah, it looks like we're getting a lot of distortion there. But it's just starting to clip there, right? So I'm going to turn it down a little bit. Okay, so that's 11 volts RMS. I'll turn it down a little bit more. To about 10. Now it's coming down to about 5, and then we're really starting to come down. So about 5 volts. So I don't know, the distortion doesn't seem in any way that bad. And yeah, so I'm pretty happy with the stereo and its performance. It doesn't do the 0.1. It said it would do the 0.1 at the full output. And that doesn't seem to be the case, but it's still not that bad. So, okay, so things are going great with the stereo. And so I'm just about to wrap it up. But one thing I wanted to check was the bias current in the amplifiers, or in the power amps. And this amp does not have an adjustable bias, but I thought it'd be kind of fun to check it anyway. So they've got RM25, or the resistor 25 and resistor 26. They set the bias at kind of a fixed level. And I thought about maybe putting a trimmer in there when I had it all apart. I mean, that could be something you would do. If I put new transistors in, I would definitely do that. But they say the bias current must be within the range of 15 to 110 milliamps, which seems like kind of a big range. But so yeah, so it's well, all I'm going to do is put a voltmeter across the big power resistors, and that should give us the bias, the voltage across those two resistors. So let's take a look. Okay, so I have the stereo on. I'm hooked up to an 8 ohm load. The volume's down. And here are the resistors right here and here and here and here. And I've let the stereo warm up. Was playing some music and it sounds pretty good. But then what we really want to do is just see what our voltage drop across these two resistors are. And on that one, it's right about 40 millivolts. That seems perfect for what they're recommending, although they give quite a large range. But and then this one, 53, a little bit higher, but not much. And so the bias looks good on this. And if you were to like replace the power transistors on here, or that value was way out of tolerance, right here, I'm going to see if I can zoom in on it. Right here, the resistor actually says bias on it. So I think if you put a pot in here, and there's another one, let's see, here's the other one right there. Here's the other one right here. It actually says, I was looking around, and here's the other one right there. I was looking around for it and looking for the number, and then it says bias right underneath it. So that makes it pretty easy. So with that, I think I'm done working on this guy. Well, that's the video on the Kenwood KR 2090. It's a very humble receiver. I think it's got good performance for what it is, and it was kind of fun to work on. It wasn't too hard. A little bit of farting around because there's no bottom access to the circuit boards, but that's all right. It sounds really good. And so if you enjoyed watching, please hit like and subscribe, and thanks for coming along.